Yes, assignment number 5, alkyl and aryl halides. As usual, first question is nomenclature. CHF2, CBr, ClF. These are two carbon atoms, that is, it's a derivative of ethane. And on the basis of lowest locant rule, if you remember, I told you, this will be the direction of counting. Alphabetically, this will be named as 1 bromo, 1 chloro, 1, 2, 2, 2 trifluoro ethane. I'll repeat, 1 bromo, 1 chloro, 1, 2, 2, 2 trifluoroethane. And we cannot classify it because there are more than one halogen atoms. Next, CH3, CH, double bond, CH, C, Br, CH3 twice. This will be the direction of counting, and IUPAC name is 4-bromo 4-methyl pentoene. 4-bromo 4-methyl pentoene, and this is secondary allylic halide. Secondary allylic halide. Next. Third. CH3, C6H5. After that, this is CH. CH2, this is C6H5. CH2Cl. This is 1-chloro-2-phenyl propane. 1-chloro-2-phenyl propane. And this is primary alkyl halide. Remember, this is not benzylic halide. This is alkyl halide, primary alkyl halide. Next question. This is a fill in the blanks for sequence. If there is something difficult fill in the blanks, then I'll explain. Otherwise, I'll just write answers. This A is obtained by the reverse arrow, that is reverse reaction. Reactant is bromoethane. With Na2S, we get thioalcohol. Thioether. This symmetrical thioether. Bromoethane with B reacts with ethanol. This is aqueous NaOH. These answers are in the sequence A, B, C, D. Understood it? Ethanol reacts with SOCl2 pyridine, gives chloroethane. Chloroethane with alcoholic KOH gives ethene. Second sequence. Normal butyl alcohol with KBr H2SO4. KBr sulfuric acid is nothing but in situ preparation of HBr. So with HBr, this will give bromobutane. Alcoholic KOH gives butene. HCl gives 2-chlorobutane according to Markovnikov's rule. AgNO2. This gives 2-nitrobutane. This is nucleophilic substitution reaction. Third sequence, of course, I need to explain this. At the end, we are given propane. This is obtained by the reaction of E with water. E is obtained by the reaction of D with magnesium diether. Now we'll complete this much. Magnesium diether means this is some Grignard reagent. And you know, Grignard reagent reacts with water to give alkane. We have studied this reaction. Now to prepare propane, there are two possible Grignards which can be used. It may be normal propyl Grignard, or it may be isopropyl Grignard. It means MgX may be attached to carbon number 1 or may be attached to carbon number 2. Both of them will react with water and give the same product, that is propane. Now we'll decide later which of the two is correct. Now, to prepare this Grignard, B should be one halopropane, and to prepare this, it should be 2 halopropane. Out of these two, maybe one is correct. Which one? That will decide later. This alkyl halide is obtained by the reaction of C with HBr. Now, what reacts with HBr to give alkyl halide? You have to think like this. What reacts with HBr to give alkyl halide? It is an alkene. This is propene. Now, propene reacts with HBr to give 2 halopropane, does not give 1 halopropane. And if this is not 1 halopropane, it means this is not the Grignard. That is answer E. And halogen should be bromine, and this should be bromine. That's how we rule out one of the two possibilities. Now, this alkene is obtained by the reaction between A and B. Alkene is obtained by dehydrohalogenation of alkyl halides. So this is alcoholic KOH. A may be 1 halopropane or 2 halopropane. Both answers are correct. 1 halopropane or 2 halopropane, both answers are correct. With alcoholic KOH, we'll get the same product, that is propene. Now, last fill in the blanks. Ethane is obtained by the reaction of B and A. B reacts with C to give Grignard, and Grignard is CH3MgCl. It means B is CH3Cl, reacts with magnesium triether to give Grignard reagent. These are answers for B and C. This reacts with, there's a Woods reaction to give ethane. So A is sodium triether. These are answers for A, B, and C. Grignard reacts with water to give alkane, that is methane. Explain why. You'll find both answers in your notes. What happens when 2-bromopentane is heated with alcoholic caustic potash? You have to write the balanced chemical equation, and after balanced chemical equation, you will write that when so and so is done, it undergoes dehydrohalogenation to give 2-pentene according to Sazov rule. According to Sazov rule. It means in the statement, in the write-up, two important terms have to be included: dehydrohalogenation and Sazov rule. Next. Dextrorotatory 3-chloro-3-methyl-hexane. This is dextrorotatory 3-chloro-3-methyl-hexane is reacted with aqueous NaOH. Now, listen carefully. This is what nothing but nucleophilic substitution reaction. Second thing, you have to see carefully, this alkyl halide is a tertiary alkyl halide. And tertiary alkyl halides undergo NSR preferably by SN1 mechanism, not by SN2 mechanism. And when reaction takes place by SN1 mechanism, product is neither dextro nor levo. It is mixture of the two. That is, we get racemic mixture. So you're right that when dextrorotatory so-and-so is reacted with the aqueous NaOH, NSR takes place, listen very carefully, NSR takes place according to SN1 mechanism to give a racemic mixture of 3-methyl-3-hexanol, right? Racemic mixture of 3-methyl-3-hexanol. Only writing balanced chemical equation will not fetch you full marks. Let us say this question carries 2 marks. You'll get 1 out of 2 if you do not write proper statement. Next question. How will you convert 1-chloropentane into 3-chloropentane? Now listen carefully. Whenever we want to shift the position, changing the group also but mainly shifting. Shifting can only be done via alkene stage. It means we'll have to convert this into alkene, then only shifting is possible, otherwise not. Now, alcoholic KOH will get 1 pentene. Add any HX, will get 2 halopentane according to Markovnikov's rule. We have to further shift. For further shifting, again alkene, alcoholic KOH, 2 pentene is obtained by Sazov rule. Now add HCl according to Markovnikov rule, will get the required product. 1 propanol into 2 aminopropane. In this case, we have to shift as well as we have to change the group. Main is shifting. Shifting means alkene has to be prepared. You can use any method to convert alcohol into alkyl halide. Alkyl halide into alkene, alcoholic KOH. Although we can directly convert alcohol into alkene, this is some reaction which you studied in 11th standard as well. This is what? Dehydration of alcohol. Concentrated sulfuric acid at 170 degrees centigrade. Although you'll be studying this reaction in the next chapter of organic chemistry, if you remember, you can directly use. Now, add any HX. According to Markovnikov rule, you'll get 2 halopropane. Replace halogen by NO2. I taught you one reaction, rather 3 reactions, Hoffman's ammonolysis. In one of those Hoffman's ammonolysis reaction, product is a primary amine. So this is reaction with ammonia. This is reaction with ammonia. Next, bromoethane into 3-hexane in 1 step. Let us say these 2 carbon atoms come from this reactant, remaining 4 will come from the other reactant. This is nucleophilic substitution reaction, you'll find in your notes. This is reaction with sodium alkynide, sodium salt of alkyne. Next, 2 propanol into 1 propanol. Again, shifting has to be done. We use these 2 reactions today only, therefore I'm not writing how to do this. I told you in the previous conversion also. Now, anti-Markovnikov addition. HBr in the presence of organic peroxide. After that, aqueous NaOH will get the final product. Next question. Identify chiral and achiral molecules from the following. Now, what you have to do is write structures of these compounds given and check which of them contains a chiral center. The one which carries a chiral center is chiral, and others are achiral. So I'm just telling you the answer. I'm not explaining. In case you want me to explain, I'll do one of them. A, C, and F. A, C, and F. These 3 are chiral. They contain chiral center. Others are achiral. If you want me to explain, I'll explain one of them. Tell me which one do you want me to explain? No one? It means you're not trying at all. Which isomeric pentane on photochemical chlorination gives a single monochloride? Answer is 2,2-dimethyl propane. Right? 2,2-dimethyl propane will give only one monochloride on chlorination. 3 isomeric monochlorides. For this answer is normal pentane, that is pentane. It will give 1 chloropentane, 2 chloropentane, and 3 chloropentane. 4 isomeric monochlorides. For this answer is isopentane, that is 2 methyl butane.